Hello, and welcome to Section 5 of the Hidden Risks for Green Buildings course. The objective of Section 5 is to investigate factors that can increase the pollutant load in a building. The focus of Section 5 is to investigate reducing indoor air quality problems resulting from the construction renovation process in order to help sustain the comfort and well-being of construction workers and building occupants. During construction, there can be increased pollutant load in a building because of various factors: heavy particulate load and the off-gassing of formaldehyde and volatile organic compounds from newly installed products. There are various methods of controlling this additional pollutant load, such as additional air filtration, the use of temporary air handlers for heating and cooling, and flushing out the building with additional amounts of outside air. As proposed by LEED Credit 3.2, building flushout can occur either late in the construction phase or after the building is occupied. While the use of outside air to flush out the building may reduce the concentration of off-gassing, it can also inadvertently cause moisture problems. Although the moisture problems may be short-term, decreasing after the flushout is finished, the resulting mold problems could be long-lasting. The environmental quality credits related to the construction indoor air quality management plan allow for two separate approaches to building flushout: one during construction and an alternative plan after occupancy. Both approaches involve a substantial amount of outside air volume, 14,000 cubic feet per square foot of floor area. Whether this flushout occurs rapidly over a several-week period during the late stages of construction, or more slowly over several months during post-construction, moisture problems are likely to result in many parts of the country during the summertime. Increased building ventilation over the design amounts can create a range of problems, such as inadequate sizing of the air filters and an inability of the air conditioning equipment to handle the increased moisture or latent load. While the LEED credit mandates a 60% relative humidity maximum level during this flushout period, this requirement may not be feasible with the building's equipment. Since final building finishes should be in place prior to flushout, otherwise there are no materials to off-gas, it makes the entire building susceptible to mold growth problems. If building flushout occurs after occupancy, then even the furnishings are susceptible to moisture problems. In a typical 100,000 square foot building, the amount of outdoor air required to meet the flushout portion of this credit is 1,400,000,000 cubic feet. This amount of air volume in the eastern portion of the country during the humid summer months can be equivalent to over 200,000 gallons of additional moisture introduced into the building. This moisture is in addition to the normal moisture load from construction activities, cleaning liquids, or construction-related moisture from curing concrete, paint drying, etc. One of the additional risks with conducting building flushout, especially in an occupied building, is that it is usually done in the evening when the heat load is the lowest and the moisture load is the highest. This can result in even greater relative humidity levels in the building because the unfavorable ratio of sensible to latent load can cause overcooling of the building, resulting in flash condensation. The additional likelihood that the heating, ventilation, air conditioning system might still be unbalanced at the time of the flushout increases the potential for moisture problems as the result of this process. This ends the Section 5 learning content material. Please proceed to the self-assessment for Section 5 or review the section video again.